Hello, everyone, and welcome to this webinar. My name is Sandrine. I am the Marketing and Communications Officer for the Global Databases at WIPO. And today I will show you how to perform chemical searches in PatentScope. To kick things off, I'm sharing a unique version of the periodic table of elements. What's special about this table, it actually connects each of the chemical element to a patent document so that you can see those compound in inventions. You have the URL of it at the bottom of the screen, and I'm showing you an example here with oxygen so that you see how this table works. I actually came across this table thanks to my LinkedIn community when I asked for chemistry learning resources. So I'm still on that journey trying to learn more about chemistry. Before we dive right into chemical searches in PatentScope, some practical information. As you will be muted during the webinar, if you have any questions, concerns, or comments, please use the question and answer little icon that you have in your control panel. I won't be able to look at those questions while I'm presenting, but we will conclude today's webinar with a dedicated question and answer session in which hopefully I'll be able to cover most of the questions. I did this session on Tuesday evening, and the presentation is quite long, and we didn't have a lot of time for questions, so don't worry, it might happen again today, but I will reply later on individually by email. About email address, this is our email address that you can use at any time when you use PatentScope. If you have any questions or if you want to provide feedback, don't hesitate. Our email address, very straightforward, patentscope@wipo.int. All right, so let's get started. First of all, how do you access the chemical searches in PatentScope? It's available freely at the URL you see on the screen. It's free like PatentScope, and everything you do in PatentScope stays confidential between you and WIPO. For chemical searches, you will need to have a WIPO account and to be logged in. If you don't have such an account, you can easily create one. It's also free of charge. Then you will have access to the chemical compound from the search menu. There are three different searches available in PatentScope: the structure search, the substructure search, and the Marcus search. We will take a look at those ways of searching chemical information in that order, from sort of the easiest to the more complicated one. So we'll start with Marcus. I see that I might have some issues with the sound. Some people are telling me that the sound is low. Let's see. Let's see if we can improve this before we go on. Is this better like this? Can you hear me better now? Just let me know. Is the sound louder? Well, let's see if I have some feedback on the sound. All right, wonderful. Perfect. Sorry about this. All right, so let's start with the easiest way of searching in PatentScope for chemical structures, which is the structure search. This was actually the first chemical compound way of searching that became available in PatentScope a few years ago. The idea of the structure search is that it recognizes names and structures of chemical compound in patent text as well as in embedding drawings. And then Those names and structures are standardized into INCHI keys. And the good news is that INCHI keys can be used also by non-chemists. Let me tell you a bit about those INCHI keys. They are short fixed length character signature based on the code of the INCHI string. And it provides a unique and robust tag that is approved by the International Union of Pure and Applied Chemistry for a chemical substance. The INCHI is a textual representation of a chemical structure, making it easier for researchers to search for chemical online. And an INCHI key is a condensed fixed length. It has 27 character digital form taken from that INCHI. This is a more compact and standardized way of identifying chemicals. If you wish, the INCHI is more descriptive, and the INCHI key is designed for a quick, specific search and also linking it to patents and patent databases. Here you have an example for ibuprofen. The structure search in PatentScope is focused on developed exact chemical formula, which means that it works with specific identifiable chemical structures. This is different from microstructure that we will take a look at the end of the webinar, where you will have placeholders like R and have multiple variables positions to represent a collection of related chemical structures. So this structure search targets specific, precise compounds. In PatentScope, the chemical searches is available for the following collections. You have the date range. And if you go to the coverage page, which is available in the help menu, you will have this dedicated column called chemical data, where you see exactly the date ranges and for the different collections. Here you see the first one is the PCT. In terms of updates, it's usually 1 to 2 weeks after publication for the exact structures. Then for the substructures is once every 2 months. We use those IPC codes to select the documents that were indexed for the chemical structures. And in terms of fields, those are the fields where the chemical structures are searched: the title, the abstract, the description, and the claims. In terms of limitation, we can say that they're long automated procedures without any supervision. So they can be mistakes. Not 100% will be recognized. This is the same problem as with the OCR. For PCT application, it will depend on the quality of the OCR. It will not work on simple formulas like H2O. And as you saw, not all the collections and therefore not all the languages are covered. But it is still useful. Why? Because terms like aspirin and paracetamol, they're not always used as such. In patent documents, you will not always find those keywords. They might be, the inventor or applicant might have used the structure instead of the keyword. And there are many different ways to represent formulas. So using it, you will be able to expand your searches. You have 3 options to perform this structure search. You have the convert structure, upload a structure, and the structure editor. You see here on the screen, we have a search for scaffold. This can lead to some confusion. So let me clarify. When we mention scaffold here in this specific case, it's the basic skeleton of a molecule. And what it means is that the secondary information is ignored. So it's not the scaffold as in a Markush formula. If you wish to upload a structure, just click on the tab here, and then you have different options. You can upload a MOL file or an image file, such as PNG, GIF, TIFF, and JPEG. Here's an example. Once I uploaded my structure, it will appear in the structure editor. And this structure editor can also be the starting point of your search. You can use the structure editor like you would draw on paper. There are different options to build your structures. You can indicate undefined double bound stereochemistry in the structure editor. To do so, you select the bound and then right click in the query box, and then you select edit bond and then the double either. Here you go. And then you can save in a MOL file this structure. You have a button here to do to save it. Another option is to convert a structure. This is what I use as a non-chemist. It's very useful as I can enter a common name. You can also enter INN, INCHI, and SMILES. Here I show you an example, just entering caffeine. I can see it in the editor. I have some useful information such as the INCHI, the INCHI key, the molecular formula, and the molecular weight. You also have this button evaluate at the bottom on the right hand side. This is when you draw a structure, you can click it in order to make sure that the structure is recognized. In your result list, you might have some documents in a foreign language. This is because we're using this INCHI key I showed you. It allows to find documents in foreign languages. And then you have this machine translation button that will allow you to translate the result list, and then you will also find it within the document. For the different parts of the document, here I'm showing you the bibliographic data, but you can also find this button in the description and claims. And this is the translated version. When you do a chemical search, you will have a dedicated tab for compounds, and then you will have an indication as to where in the patent document the compound is located. The compound will be highlighted, and then when you hover your cursor over it, the structure will be provided. You can also develop formulas like the one you see on the screen, still using the compound name. This works fine. And then I'm showing you this example. For those of you who've followed my webinars before, I usually show it, and I find it very interesting. You can enter the compound name, and then when you look at the result in the analysis, you can take a look at the publication date. So we have 94 and 95. And then when we read the landscape report on this ritonavir, we find out that the drug was actually approved only in 96. So using PatentScope, you can actually find documents before the actual approval of the drug. Now, the second way to search in PatentScope is using the substructure search. This allows you to identify specific elements within larger chemical structures. Let me show you an example. I started with a compound name here, and then to find the substructure search, you have to go to the Show in Editor. And at the bottom, you have the substructure search button. In the result list, you have the tab compound found, and just below you see the percentage that was searched. And then at the bottom, you have the option to show more if you're not satisfied with the number of results. And you will have the option to select all the results, or you can select them individually before you perform your search. Then in the result list, you will have a very long query. To see it entirely, you can click this notepad button. This will allow you to not only see the entire query, but it will also allow you to edit it if you need to add some additional search criteria, for example. And still the very useful machine translation button. You have two options, Weibo Translate and Google Translate. You can sort your result. By default, it's done by an algorithm for relevance, but you can also search by publication date or application date, either ascending or descending. And then the analysis, this is where what I showed you when we talked about the RetroNavier. This is where you can access it. You click this little graph button, and then you will have this analysis page. The information is presented by default in a table format. It can also be a chart or a time series, and you can customize the information here to a certain extent by going to the settings menu. In the result tab, you can increase the number of items you have per column. By default, it will be 10, and then you can also define the columns you're interested in. Now, some tips for searching chemical information. You can search by CAS number. To do so, you need to replace the dash by some crosses. What this does, it actually look for this specific CAS number within the document. So the CAS number has to be written in the document, like it's the case here. So it's not like searching a proper CAS number in the CAS registry, but it's a way to find documents citing those numbers. Then if you would like to combine different information, let's say you find a compound and now you want to add some keywords, maybe some wildcards, just search the compound first and then build your query with the Boolean logic. Here, for example, I added some keywords containing wildcards in the English text, and this is my new result. Now, if you would like to add other languages, you can, for example, look for those keywords in Clear, available from the search menu. In the result, you look for the Japanese that you just copy, and then you paste it into the search box, still keeping the chemical field so that you can combine those. And then, of course, you use the machine translation so that you have the translation initially of the result list and then of the documents themselves. You can combine them with lots of criteria. For example, applicants. So you start with the chemical compound, you use the Boolean logic, and then you can select what you're looking for. You start typing what you're looking for, and then you select them from the drop-down menu. So here, for example, I'm looking for this specific applicant, Novartis. Here I open one document and I have in the applicant field Novartis and then my compound with the structure. You can combine with a country, meaning You can target a specific collection. By default, it's searching in all the collections. Remember that not all the collections are covered in PatentScope. A good way also to cover the other collection is to use the keyword in that case. And you can click the office name in the result list, and then you'll be able to refine your options. You can also combine two compounds. To do so, you need first to start with one of the compounds. Once you have the INCHI key, you copy it and paste it to Notepad, for example. Then you search your second compound, and you just, again, using the Boolean logic N, you add it to your search. And within your document, both compounds will be highlighted and the structure provided. And it's the same principle with combining with date, IPC, and so on. And then if you would like to restrict to the claims field, this is the magical formula that you need to use. You use before 1000 and description and claims before 1000, then this allows you to target the claims using the before operator and playing with the claims and description. All right, so this covers the first way of searching for chemical compounds in PatentScope, the structure and the substructure. So now we move on with the Marcus search. Marcus structure is a representation of a group of related compounds in a simplified form. Its function is a generalization of a specific chemical structure where you have an invariant core, which can be called a scaffold. This is why I highlighted before this scaffold box that could be confusing, or it's also called a master structure, and a series of possible variation attached to it. Those variation could be different atoms, groups, or other features, and are often used in patent claims to protect a range of related compounds rather than having to protect those compounds individually. You can think of a Marcus structure like a sandwich recipe. In the recipe, some ingredients can be swapped out. For example, it could be specified a sandwich with bread, a spread, it could be butter or mayonnaise, and a filling, chicken, tuna, or egg. This describes several possible variations of a sandwich in one single statement. And this is how a Marcus claims in chemistry outlines a core structure, like the bread, with possible variation, like the spread and filling, and therefore protecting a family of related compounds instead of individual ones. This could be a Marcus structure with a R1, CR2. In this case, R1 and R2 represent different chemical groups, such as hydrogen, methyl, ethyl, or more complex molecules. This allows for a broad range of possible compounds to be covered again by one single claim. This is a very basic formula to explain the concept, but usually Marcus structure, they are much more complex and incorporate multiple variable position and variation across different bonds, functional groups. I'll show you another example. This is a typical Marcus structure taken from a patent document. Here you have the reference if you want to take a look at it, because I was unable to copy and paste it because it contains pages and pages. Even when the Marcus structure is relatively simple, it can still cover thousands of compounds. And the more complex one will include over 100,000 variations. In Marcus claims in patent documents, as I said, it could be pages and pages, and this is especially true when it is about a pharmaceutical or chemical compound. Often a marker structure will include a base or core structure, then you have multiple sets of alternative or variable groups. It contains also detailed definition for those groups, optional required substitution, the occurrence counts for substitution, and also specific or generic or even textual definition. And those components help to define the scope of the patent claim. And it makes it clear which chemical compounds are covered, even if there are numerous variations. So as I explained earlier, Marcus formula is a generalization of a specific structures. It consists of an invariant core structure that act as a scaffold or a master structure, along with various possible variation. There are actually four main types of variation. The substitutant variation. This refers to different groups that can be substituted for a given position. And these variations allow for significant diversity in the chemical structure. Then you have the position variation. This occurs when the group are variable points of attachment. Often they're represented in ring structures, and you also have the frequency variation. Repetition groups or multipliers come into play. This allows for the repetition of a group within a structure where the number of repetition can be defined within a specific range. And then the last one is the homology variation. And this involves the use of generic nodes that represent homologous groups of fragments. And those can be expanded without limits. All those variations are captured and are therefore searchable in patent scope. Why is Marcus used in patents? We already saw a little bit of it. It allows the protection of a wide range of compounds under one single claims. Inventor can claim multiple compounds, protecting the invention without actually revealing the exact molecule. And rather than listing each compound, the Marcus structure covers variant and substitute. So this makes the patenting process a bit quicker and more streamlined. And then new variation can still be protected under this initial claims. This ensure that competitor will not be able to exploit the unlisted compound. And then also the large pharmaceutical companies can use those to prevent generics from entering in the market. Now, of course, there are some challenges when it comes to working with Marcus structures. And as you can see, the list is quite long because the nature of the structure, the fact that it represents thousands, even more than that, compounds, it makes the interpretation, analysis, and effective searching challenging. And then if you don't have precise query, you will have an overwhelming number of results, which again makes it difficult to isolate really the documents that might be of interest to you. The analysis of similarity, identity, and functionality will require some deep expertise in evaluating marker structure in an accurate way. Sometimes also just the visualization can be difficult, especially when you try to compare. Sometimes gaps, overlaps, or exact matches might not be so obvious. There's also no universal standard for representing Markov structures, which makes it difficult to share data, compare those data, and also to perform searches across different platforms. And then the fact that the Markov structures have varying significance makes it difficult to also define how relevant the search results are. And there are also a limited number of databases that cover the Markov structures. So let me tell you about what is covered in PatentScope. We have the data available in PatentScope is actually produced by Clarivate, and it's part of the Derwent Markov resource. It contains approximately 2.5 million Markov structures. The collection comes from two main sources, this Clarivate Derwent World Patent Index, as well as the partnership Clarivate had with the National Institute of Intellectual Property in France for the back file. Each structure is assigned a unique Markov compound number, linking it to its original patent. In PatentScope, you can access data from the 6 major patent offices that you see on the screen with the starting dates. The database primarily captures the structure from patent claims, but it also includes broader definition from the description when it's relevant. And then the collection spans a wide range of chemical structures, including organic compounds, organometallics, inorganic salts, and metal oxides, and also some coverage of alloys, intermetallics, and polymers. For polymers, the data is not comprehensively indexed in the system, and it's typically limited to the cases where the Markov structure are for small molecules. So this is a limitation that you have to be aware of. You can use the superatoms. Those are 3 letters generic group definitions to represent common chemical groups. For example, the CHK superatom represent an alcohol chain, which can be used to generalize various alkyl or hydroxy groups in the structure. And we also have those atoms for a wide range of functional groups, including aliphatic or alicyclic rings, aromatic, heterocyclic, and fused heterocyclic rings. If you use those superatoms, they will help capture frequently occurring groups in Markov claims, and therefore simplifying the representation of chemical complex entities. To incorporate superatoms in your Markov structures, you go to the structure editor that we looked at before. Here I've used 2 superatoms before performing the search, and to add this, you first draw your core molecule, right-click on the atom you want to modify, you open the Edit Atom Properties, and then under this 3rd tab called Generic Atom, you will find the option for these common superatom types. All right, so now let's perform an actual search. There are 3 different ways to perform Markov searches in PatentScope. The first one is the enumeration. The second one is the indexation that has 2 options, exact or substructure search. About enumeration, it's using enumerated Markov structures. So what does this mean? It refers to listing the first 500 simplest compounds that are taken from a Markov formula. Then these compounds are indexed in a new field called enum. I will show you in a minute. And then this will allow you to search for Marcus formula, just like individual compound explicitly cited in patent documents. The enumerating of the Marcus structure uses a dedicated software that enables rapid searches within the documents that contain Marcus formulas. And those documents are annotated with INCHI keys, similar to what we saw before for chemical-related patents to be indexed. If you want to perform an enumeration search, it's very easy. You just have to tick one box and then click the exact structure search. Here I did a search for simeditin, and I made sure I ticked the box, and then I click the exact structure search. In the results, you will have the chemical field that we saw before, chem field, and then next to it, you have this new enum field. With this, you have a more comprehensive result list, including both Marcus and chemical compound. And then again, you can refine those using the Boolean logic as we saw before. The advantage of using the enumeration, it's only one box tick to search Marcus formula, which is very good. Then the response times are very, very good. It's executed within a matter of seconds. And then you can combine the result with more information. So it's pretty efficient, pretty straightforward. Here, for example, I kept my query, so I kept the chemical field and the enumerated field, and I added an applicant and a publication date. Of course, there are some disadvantages. The Marcus enumeration algorithm limits the result of to 500 INCHI keys. Therefore, more complex and more distant structure from your initial query will not be retrieved. And then it's an exact compound search. Only exact searches for compounds are possible. Therefore, it's limiting the flexibility in capturing the variations. All right, so let's take a look at the second way to perform a Marcus search. That is called by indexation. So in this case, the Marcus structures are expanded as superstructure containing the whole information of all the structure represented by the Marcus structures within one database record. Each type of variation is expanded within the superstructure with certain limitations. In the group that followed the webinar on Tuesday, they asked me to prepare a slide with those limitations. So this is what I will do before I make the slides available, so that you have also the list of those limitations that I will talk about now. First of all, the repeating groups and multipliers, they will not be fully expanded. That's because of the limit of the system. We can store about 10,000 bounds and about a maximum of 30,000 atoms. As I mentioned, the superstructure in Marcus when it comes to indexing are very large and complex. And to handle this complexity, we store generic nodes with their full information. For specific nodes, which means actual atoms, we create what we call spin-offs. If an atom is part of a ring, it generates a generic ring spin-off. And if it's in a chain, it will generate a generic chain spin-off. These spin-offs, they will help the system match queries more efficiently and ensuring better search result, even when the structure is highly variable. Therefore, for a query to return result, it must match at least one node in the database structure. This means that atom nodes in your query can match either exact atom nodes or generic nodes using the spin-offs. In a similar way, generic nodes in the query can match either other generic nodes or real atoms through spin-offs. And this process ensures a broad but still precise way of finding relevant result while navigating the complexity of those large Marcus substructures. And also in terms of multipliers and repeating groups, we have certain limitation in pattern scope. A multiplier, which is a structure fragment that connects to the main structures and can be theoretically can have theoretically a range of member m to n. In pattern scope, we expand only up to 9 member as a fixed limit. And for repeating groups, we only store one fragment and we ignore the defined ranges. What does that mean? It means that when you build your queries, you need to avoid using multiple elements from repeating group, as the system will only recognize one single instance. And if you don't do that, you might have no hits. All right. So you can start with the compound name like I always do. And oh, it's a bit off, sorry. So it's supposed to highlight the compound name and then show in editor. The editor will be a more elaborate way for you to start your searches if you're able to draw. And then you have at the bottom of the page the marker search. And here you have two options, the substructure and the exact. Here it's important that you know that exact in the context of Marcus doesn't mean the same thing as it did for what we saw in the beginning for the fully defined structure. Because Marcus covers a broad range of related compound, an exact structure will return results where at least one of those compounds is an exact match to your query. So in practice, the exact search is a special form of a substructure search where every node in your query is treated as closed. This means that it's fixed exactly where you drawn it, with a specific substitution count. No extra connection beyond what you specified are allowed. This ensures that the search retrieves all the structure where your query appears as complete. And additionally, you can use all the standard query feature while building your Marcus queries. In the editor, as I showed you many times now, you can access by right-clicking on the drawing, the atom properties, etc. And also keep in mind that the stereo centers in your queries are ignored. That's because Marcus structures typically don't include stereochemical information. All right. So once you perform your query, you will have a tab for the found Marcus formulas, and then again a percentage of the search performed. To access the different results, you can click the numbers. Those are the unique numbers that are provided by Clarivate. when you are happy with the number of results, you can search, you can select the ones of interest, or you still have the show more button that we saw before if you want to find more matches. Always you have an indication as to where you stand with the percentage of result covered. And you have this batch button so that you can run your query in the background. You give your Marcus batch a name. Then you will have a summary of the Marcus batches. Initially, it will be queued. And then when you go back to your account, you have this item Marcus batches where you can access all the Marcus batches that you ran. Once it's completed, you have the number of items and you can access the result by just clicking the magnifying glass. And now you have the total number of results found. You can also use the MN field that will allow you to search directly if you have those Marcus numbers provided by Clarivate. And then you have the documents that contains a Marcus tab, and you have those Marcus number. If you want to see the 500 structures associated with a Marcus number, you will have to perform a search, then open one document in the Marcus tab and select the enumeration to see those. So this is an example of a Marcus search number. The Marcus tab, and then you can see here the formulas by clicking the little arrow pointing down. The advantages of using this way of searching, all the structure matching a given Marcus structure will be searched, as opposed to the 500 simplest one with the enumeration. In this case, also, you search not only for the exact complete compound, but also for compounds specified with the variation groups. And then it's a more advanced way of searching Marcus structure. The disadvantages, the response time can be very long. The repeating groups are not supported, as I explained, and then it's quite complex to use it. You need some chemical knowledge in order to understand what you found in your results. Now, to conclude this webinar, I'll just show you how you can also access PatternScope information from PubChem. If you use PubChem and you search for a compound, like here I search aspirin, you have a dedicated tab, patents, and when you click on it and you open one document, you will have access to the document in PatternScope with a direct link, but this is for PCT applications. And then you have to be logged in before you do this. If I'm logged in, I will have the compound tab. But if I'm not logged in, then the compound tab is not available. So if you want to use searches from PubChem, remember to first log in into PatternScope so that you can actually see the compound tab. All right, so this is what I had to tell you today. I tried to summarize a little bit what can be searched here. We often have questions about polymer. Unfortunately, polymer cannot be searched in PatternScope. You can also not really search peptides. but you can search simple transition metal complex. Uh, Basically, any compound that can be represented by an ICHI key can be searched in PatternScope. All right, so about webinars, there's a dedicated web page for PatternScope webinars. You have the URL here. This is where you can register for upcoming webinars. If you have suggestions for the next webinars, please let me know. And this is the button where you can access all the previous sessions with the slides. This is where the slides of this webinar will be posted. If you're interested in Marcus structure, I would encourage you to take a look at the webinar called Marcus Searches in PatternScope. This was done together with some Marcus experts. So if you are interested, I would encourage you to take a look at the slides of this webinar. There's also, I think the recording is also available. So take a look. It's available in the section 41 to 50 if you want to find it. I would also encourage you to join our LinkedIn PatternScope user community group. It's a nice way to stay in touch, to exchange ideas. This is what we use also to find out what our users would like. Today, I will post a poll on searching IPC ranges. I'll encourage you to join and to take an active part in this group. This is a closed group, so it's also limited what you post stay within this group. All right, so we don't have a lot of time left for some questions. I'll still will take a look at some. I will reply later on by email. There were some questions about the slides that I answered. There were questions about how to draw, which was also covered. There's a question about a handout presentation. There's a user guide where you will find information also when you use the chemical compound search. There's a little arrow pointing down that takes you to a guide for chemical searches. I'm also considering creating such a guide if there's interest so that users have more support when using the chemical search. There was a question of batches. It's just a question of running the search in the background so that you don't have to stay there and click on it. It will run for you and then you will find it in your result list. There's a request for a LinkedIn group which does chemical searches using PatternScope. That will be a bit too specific. You're welcome to use this PatternScope group I showed you on LinkedIn. This is perfectly fine to ask all your questions and exchange with other chemists. There's a question about a certificate of attendance. Unfortunately, there's no certificate available. If you want to search INN in PatternScope, this is also available. There's a question about limitations in terms of batches, not that I'm aware of. This allows you to run those long queries in the background, and I'm not aware that there's any limitation. All right. There was a question about specifying the elements, so I think this was covered also. I will take another look if I missed some of your questions. Don't worry, I'll take a look later on and I will reply individually by email. I'll take one last question about the format. So the format is the mole files as well as the image files. This is what is supported currently. All right, so with this, I will conclude today's webinar. And again, don't worry if your question is still unanswered. I will take a look at the list of questions. I still have a couple to answer from Tuesday, so no worries. I'll make sure I reply by email. The slides, I will upload them here on this page, and you have to go to the All PatternScope webinars. It might take a bit of time if I add a slide for the limitations, as it was requested, so maybe next week it'll be available. All right, wonderful. Thank you so much for your kind attention. I hope that you find it useful. I hope that you will use PatternScope and its chemical searches. Don't hesitate to provide feedback, contact us for questions, and join us on LinkedIn. And with this, I conclude today's webinar. I wish you a very good day or a very good night, depending on your location, and goodbye for now.